Well, welcome to our first keynote here at Visual Studio Live 2023 in Redmond. It's fantastic to be here in person, is it not? Now, notice the weather. We gave you that beautiful sunny weather, so don't buy the crap that it's gloomy and unlivable up here. It's a beautiful place. So at lunchtime, maybe go outside. Now, you're developers, so I understand, not more than 10 minutes, but get some sunshine. So, want to do a thank you to Microsoft for allowing us to have this wonderful event here. And those folks in the back, come on in. Come grab your seat. We're going to get started. I'm just doing announcements. Come on in. Microsoft helps make us happen in this lovely venue here on the Microsoft campus. You have access to the store. We're going to have some great Microsoft people here tonight, so thank you for them being here. And thank you to our gold sponsor, Progress, for showing up and sponsoring the event. If you haven't found the Wi-Fi by now, I really don't think you're a developer, but just in case, it's MSFT guest, MS event 452 AN, or talk to your neighbor. And I know talking to neighbors is hard, but be nice. I know, but I'm going to beg evals. We do look at them. The show looks at them. The speakers care. It's how we find the right topics and the right people to present. So please fill out the evals for the sessions. And then at the end of the week, you'll be able to do the overall conference eval. I know it's a little extra, but they'll trade you that eval for a t-shirt. And we're geeks, and that's how we fill out our wardrobe. So you got to do that. Now, don't forget there's a raffle. Get your ticket stamped by Progress and turn it at the registration desk. The drawing is tomorrow at 2:45 p.m. tomorrow. You must be present to win. Ooh, there's some real prizes here. A Surface Pro, a projector, a MetaQuest VR, ooh, Yeti, I want that, and a free conference pass for next year's shows. All right, what else here? Oh, tomorrow is our table topic lunch. So this is where the speakers that are here, as well as folks from Microsoft, will have tables that they'll be sitting at, so you can come and ask some questions, talk to your peers about topics you care about, or you're feeling antisocial, you can avoid that and just sit at a table that doesn't have a speaker or other people. I'll have a table that says Brian on it, and you can just run the other way, sir. No, please come sit with me. Don't leave me alone. It'll hurt my inner child. We have a bunch of great sessions coming up today. Hopefully, you've already gone to some, and you've got more coming up. Tonight is our welcome reception, and Microsoft Ask the Experts. We have about 10 different teams from Microsoft showing up. They're here to answer your questions, to get your feedback, and they'll probably have questions for you. So come down, have some drinks, have some food. It'll be downstairs in this building at 4:15 to 5:45. And yes, you'll still be able to get the buses back. You're not going to miss anything. So come and be social, have some vittles and some drinks. I don't know. Are we allowed to have alcoholic beverages on campus? I don't remember. Yes, I don't know. We might have booze. We might not. But really? Now, wait, real quick. Was that a boo because you want booze or because you don't want booze? Oh, you want. Okay. I will find that out and let you know at the end of the session. All right. I think there will be beer and some wine. Okay. Tonight. Oh, yes, there is booze. Yay! All right. And of course, if you don't drink, you don't have to. Oh, my Lord. All right. I think we're getting down to the end here. So, last thing to bring up is bag check is Thursday and Friday at Building 92 if you want to leave your stuff so you don't have to carry it around. And don't forget, the beverages in the fridges you can drink from. So the soda pop, the fizzy water, the regular water, just walk around the corner. There's a couple of them in the building. Feel free to do that and use that there for our enjoyment. Okay? Thankfully, that is it on the announcements. So now I get to do my favorite part, which is introduce our keynote speaker. So this lovely person here is Amanda Silver. She has a wonderful title of Corporate Vice President, and she works, though, in one of my favorite parts of the company, Developer Division. That means two things. Number one, she is one of us. She cares about us. And as someone who's known her for a long time, Amanda is very accomplished. She's been in the industry for a while. Her and I both met in the days when Visual Basic 6 was a thing. So the classic one based on COM. And why does that matter is because Amanda writes code. Now, she probably, unfortunately, writes a little more email and PowerPoint than she'd like to, but she is one of us. And she has grown into this role as a CVP who cares about building great experiences for us, for developers. She wants you to have the best experience, and that experience is going to be with awesome tools like Visual Studio Code, and the larger Microsoft developer tools. So please give her your attention, listen to some of the great stuff that's coming in the future, and if you get a chance, let her know what you think about the products. Tell the team here, they are listening, they do care, they build this for us. For my dear friend, give a warm round of applause for Amanda Silver.
So as I was saying, I've been working on developer tools at Microsoft for 22 years. I've always worked on behalf of developers at Microsoft, and now I actually, in addition to running, I'm the head of product for all of the developer division at Microsoft. So I work on Visual Studio Code, .NET, TypeScript, all of your favorite products. That any product that basically targets developers is something that we work on. But in addition to that, I also run the team internal to Microsoft that takes our products that you use and customizes them, and then provides special support for the internal engineers inside of Microsoft. So a lot of what we've been working on for the last couple of years has really been inspired by what Microsoft's own internal usage also looks like. And so you're going to actually end up seeing a lot of that today in terms of what I talk about. Generally, I think we're in this era where the developer experience is really getting dramatically enhanced by the power of the cloud, which now has unlimited storage, unlimited connectivity, and AI. So we can now learn from how you use your tools, how other people write code, and use that as a mechanism to make you more productive. So I think I just mentioned that. Early in my career, I really discovered that I am inspired by developers. I have been working on behalf of developers for 22 years because I find no other customer as appealing as developers, because you guys are early adopters of technology, you're technology enthusiasts, you're constantly giving us amazing feedback on the products, and I really live for that fast feedback cycle. So I just wanted to say I appreciate you guys being here. And really, I want to focus on enabling you to build whatever you're thinking of. So, we are really inspired by you. We actually come and we watch developers in the context of where they work to then figure out what we need to go build. What are the challenges that you're faced with day to day? How can we think about the entire ecosystem of developers and how they can work together to actually become much more efficient and capable in terms of what they're targeting? So we're constantly trying to work on making sure that you can go from your concept to your code to your customer as quickly as possible. And so what we're seeing is that there's a couple of disruptions happening right now. We know that you want to spend your time and your creative energy and your bandwidth on, you have to adapt to the hybrid first work environments that we're all living in right now. How do you collaborate with developers that are your colleagues, that are geographically distributed across the entire globe? That you're dealing with a lot of operational toil. And that oftentimes looks like, okay, going and figuring out what does it mean to have my solution be deployed in production, and how do I know when it's gone down? But oftentimes it also looks like paperwork, digital paperwork that you have to get through to make sure that you're actually in compliance with the policies and the standards of your organization. There's engineering systems friction that you have to deal with, that, it's not just the collaboration between humans, but also your build times might be slow. Your tests might be flaky. How can we actually make all tests get much more resilient and reliable so that you actually have faster iteration cycle times? And then also the other thing that we have to think about is the fact that you're constantly distracted. There's notifications that pop up. You have to collaborate with somebody else on your team who has a quick question. How can we make sure that you can maintain your focus and really, zone in to the code that you need to be able to write? So we are also thinking about attention and the context that you need so that you can really, put your work on the shelf on Friday afternoon and come in on Monday morning and resume that context as quickly as possible. so that you can get going. So what we really want to make sure is that, you are also focused on the code that only you can write. If you think about it, there's a ton of boilerplate code that we as an industry all need to write, right? We've all done, I don't know, how do I make a HTTP post or something like that? Like, that is not differentiated code. How can we help you write that code so much faster so that you can focus on the code that's unique to you, to your business, to your organization? And we also want to make sure that you're happy and that you're successful and that, you are able to keep the team members that you've trained, because we know you put a lot of energy into training up people onto your team. And so if there's a tremendous amount of churn in your organization, that's also cost to you. And so how can we actually make sure that your entire team actually stays happy? So internal to Microsoft, we actually regularly measure the satisfaction of developers in our engineering systems. And we actually use that as a guidance to determine what kinds of investments we want to make across all of our engineering systems and into our tools themselves. So I'm going to go through 3 different chapters in this talk. The first is, how can you optimize the developer experience for an individual developer? The second is thinking about that developer in the context of a larger team. How can I accelerate the productivity and the dev cycle of the entire team? And then really in this era of AI, how can we make it so that every developer can build an intelligent application? And it's a lot easier than you guys might think. So first, I just want to talk about the individual developer experience. So, what we really try to do, again, is to focus on the aspects that allow you to get into that creative zone, the part that's differentiated to you and your organization. And we do that by building these common foundational elements of .NET and Visual Studio and TypeScript and Python tools, etc. The Visual Studio family has 38 million developers thus far, 38 million. So incredible growth over the last decade. Use the Visual Studio family of products to write code, and it's probably beyond that. This stat is maybe a month or 2 old. Now we've grown from what was primarily a .NET developer base and secondarily a C++ developer base to now be the most popular tool set for JavaScript developers, Python developers, and really any programming language. You're probably using a Visual Studio product to do it. Now, one of the things that we really try to make sure the entire team is oriented on is, again, that fast feedback cycle. So we build systems into, whether it's GitHub issues for our open source repositories, or if it's the developer community channel for Visual Studio, that allows you as users of our products to give constant feedback that has, deep context as to what issue you're encountering in that product. And that's what allows us to create really, really high quality, products that are not buggy, that you can actually rely on for, the 8 hours a day that it really makes up your livelihood. So we recognize that these are essential products to what you need to build. So at the same time, what we're also seeing is that the complexity of applications is becoming much bigger than what it used to be, right? When Brian and I started in the industry, it was definitely like everybody was, building applications that basically ran on a single machine, and then we moved to client-server applications, and that was itself a complex moment. But now that we're moving into the public cloud era, essentially what we're building nowadays are distributed applications. And they have multiple resources that you need to build. And they might be deployed and accessed on different kinds of clients, a web client and a mobile client. That's a lot of complexity to have to manage. And so the question is, how can we actually make it much easier for you to build those kinds of applications? And part of that is making it easier for you to master new domains when you encounter them. So what we've been working on for the last couple of years is to integrate AI into the IDEs and code editors so that you guys can really move much more fluidly. We want to make it so that onboarding time, both in terms of setting up your dev box, but also onboarding in terms of understanding the domain that you're trying to tackle, is dramatically reduced. That, again, the boilerplate code that everybody in the industry has to write, you don't need to remember, you don't need to go to a browser to go look up, and that you can quickly understand the code bases that you might be new to. How can you do all of that really, really quickly? And then that really allows you to focus on the software that, again, is unique to your organization. So we first previewed GitHub Copilot, which is our AI pair programmer, in partnership with OpenAI back in June of 2021, which is over 2 years ago. We have learned so much through this, building this product, but we're already seeing dramatic effects on how it's impacting the developer experience. When we put GitHub Copilot to the test, we saw that developers were able to move through their workflows much faster than before. So we even heard that it allowed them to code at the speed of thought, right? That they are thinking and, doing the typey, and essentially it's flowing out of their fingers, and the suggestions are extremely accurate to the point that it actually makes them feel like there's not a point of friction between what's going on inside their brain and what they need to get into the code editor. So we saw that it actually helped them complete tasks more quickly, but this is what I really love. The developers are telling us that they are happier and more fulfilled because of it. And that's what it's really about, right? That you can end your day with feeling like you have less fatigue, that you feel like you accomplished more, and that's the feedback that we're starting to get from GitHub Copilot. So we're going to keep the momentum going. I actually just had a meeting on this morning with our team to figure out what are the next set of capabilities that we want to bring into GitHub Copilot. And it's going to be available for every period of the developer lifecycle. So I just want to show you a quick demo of how it's showing up in the latest version of Visual Studio.
GitHub Copilot gives you new and powerful conversational AI experience in Visual Studio, going beyond the basic code completions in favor of insights into your code, such as analysis, explanations, and my personal favorite, code fixes. I can easily ask Copilot questions in my natural language, in line with my code, and using that code context, Copilot will give me smart analysis and suggestions. On top of all this, Visual Studio teams up gather the right context to help me form some good questions in order to get some great answers. So let's take a look at an example. So Mark is a new developer. He's just joined this team. He just joined our team, and he's working on a podcast app. This app consists of a bunch of different components, including ASP.NET Core, Blazor, Maui, Playwright, among other things. And one of the first tasks that Mark has been given is having to update this class called Podcast Update Handler. But because he's new to this code base, he's going to ask Copilot, what in the world does this class even do? And sure enough, using the Copilot chat feature, Copilot will give him a brief overview of what this class is in the context of the larger project, allowing him to quickly ramp up on what this class is and be able to engage with his more experienced teammates. From there, he needs to go ahead and start updating this get new episodes method so that there aren't any UI conflicts. And as he starts to write his for each block, you'll notice that Copilot already starts to give him code completion suggestions based around the collection that he's referencing in the line previous. So after accepting that, he can then start to write his if statement. And once again, he'll get an additional completion suggestion based around the object's properties. So he can choose which property that he needs for this particular scenario, as well as the pattern that most suits him. Again, because he's new to this code base, he's also going to ask Copilot, how would you go about calling this method? And Copilot will give him some scenarios as to how to best call handle update async. But because he also wants to get ahead on some bugs, he also proceeds to ask Copilot, but what could possibly go wrong with this method? And not only can Copilot tell him a couple issues that can arise, he can then ask Copilot to just rewrite this entire method for him without in a way that will address all of those issues. And just by hitting the insert button, he can drag and drop this entire block of code, in this case, a try-catch block, into his code that addresses all of those problems. So from there, the next thing he wants to do is validate his code and make sure everything's working. So he's going to add some unit tests with the help of Copilot. And as he starts to tell Copilot to add some unit tests, you'll notice Visual Studio gives him a pre-generated question that he can use instead of having to type all that by himself. And sure enough, Copilot gives him a full series of unit tests just based off of that one command, including the mocking up of a key service. So just to sum up what just happened here, Mark was able to quickly learn up on a class and how it worked, identify and fix issues that could possibly go wrong within that code, write a whole series of unit tests, all with the help of Copilot, and it's not even the end of his first day on the job. How sweet is that? So Copilot can also come in clutch when it comes time to diagnose and debug your issues. So because Mark finished that first task so quickly with the help of Copilot, his next one is to start investigating and testing out some workflows. And along the way, he encounters an object disposed exception, which he's seen before, but he doesn't know what that means in the context of this particular scenario. So Copilot to the rescue. And Copilot will not only tell him what this exception means, but also the specifics of what's going on. So in this case, he's trying to access an object that's already been disposed of. And to fix it, he simply needs to change his method from async void to async task. So another issue that he's experiencing involves having to diagnose some issues that's returning unexpected values from some signal processing math. But why is this happening? He's not familiar with NaN either, so asking Copilot again what all of this means, not only will Copilot tell him what NaN or not a number means, but because Copilot has access to his debugging context at that particular point in time, Copilot is able to give him a contextual explanation with specific problematic variables and values. So he can get the exact issue and scenario that best suits his particular needs without having to go to Stack Overflow or without having to wait for that call from a teammate for help. And again, he can simply ask Copilot to rewrite that method so that that issue no longer occurs. So at this point, you're probably wondering, how is Mark able to do this with what appears to be such a large solution and a device in his case that's tailored for portability and battery life? How is he able to be so productive? Well, if you've been paying attention, that's because Mark has been using a Microsoft dev box. So Mark has been given a pre-configured dev box from our team with all of the tools and specifications that he needs to complete his work. This includes, in his case, a lot of RAM, a fast SSD, and the latest version of Visual Studio Enterprise. Mark also works on several projects across his org, each having their own unique tools and dependencies. And in turn, each dev box that he uses has its own project-specific configuration, making it very easy to onboard and making it easy to quickly swap back and forth between each project that he has. This also means he gets to skip that fun first week on the job of having to get past all of those initial setup roadblocks that everyone loves, right? And he can also create a new dev box from a list of pre-configured projects to start fresh and isolate his work. So of course, when Visual Studio comes into play when it comes to DevBox, it is tailor-made for it, especially in terms of performance. Visual Studio takes advantage of features such as perf catching, single sign-on, and unified settings. So you can have the same productive experience in Visual Studio within a DevBox as you would on your local machine. So as you can see, both DevBox and GitHub Copilot can help you become lots more productive and ramp up on projects and new concepts quickly. So make sure you try them both out today if you're not already.
Yeah. So I think, starting with the Copilot experience, when we started using AI in the code editors and the IDEs, what we first focused on was IntelliSense and statement completion. And it was incredibly powerful and useful for that. And we did that for just the first line. But then it turned out we could actually do multiple lines. And then it turned out as the AI got more powerful, you could actually have a conversation with the AI that had the context of the code that you were working on, and it gave you some pretty intelligent responses. And so you can see now how this AI now becomes essentially a pair programmer that's working alongside you with all of the context that you need, that you're using in your brain, in your working memory, to actually reason about and think about the code that you need to write. Now, I saw that many of you, as you were watching this demo, at first you were like, I don't believe it. I actually literally saw people shaking their heads. And after a little while, like they were like, yeah, maybe that's actually working, and then I think towards the end, people were going like, yes, this is this is awesome. These capabilities actually exist in Visual Studio Code and VS today. So if you're not already using Copilot, go and get it. Go get access to it. We are going to continuously make this better and better and better and better. And we're going to use your feedback to actually guide the developer experience so that it gets better for you. Now, the other thing that you saw in there is obviously Visual Studio. And we're really trying to make sure that Visual Studio is optimized to be used in the context of Copilot. That Copilot has the context of everything that's in Visual Studio so that we can actually make Copilot more powerful because it has the context of Visual Studio. So definitely, if you want the best Copilot experience, definitely use the latest version of Visual Studio because that's what's going to be providing the best context to the Copilot AI assistance tool. Now, as you guys saw, we have Visual Studio and we have Copilot working together, but actually all of that was inside of a dev box. Now, I mentioned earlier how I run the team that basically builds all of the infrastructure and customizes the tools for our internal Microsoft developers. And to just give you a little bit of an idea about that, this is basically the profile that we are rolling out to all of Microsoft, right? And we have thus far, over 10,000 Microsoft developers are on DevBox. We are rolling out Copilot as quickly as we possibly can to the entire company. Every developer at Microsoft is going to be using Copilot by the end of this year. Already, tens of thousands are already using Copilot internally. And really, DevBox, one of the key elements of that is that it makes it so much easier for you to set up your developer machine. Now, if you think about what it takes to actually set up a developer machine, I think for a lot of information workers, they think of setting up a new machine as something that you might do once in a job, right? You start at a new job and you set up your box for what you need to do to write email or whatever it is, or do PowerPoints. But for developers, we do it pretty often, sometimes multiple times a week. And if you think about the fact that, like, if I want to do a boot camp, I actually have to do that for everybody in the boot camp. And so that's why, in a 2-day boot camp, you might end up with a day that is purely just devoted to making sure that everybody has their developer machine set up properly. This is using, VM images, and that allows you to amortize the DevBox setup for your entire team, so that only one person really needs to do the DevBox setup. And then we can actually update those images through an automated process so that they stay up to date with what's the best security practices, what's the latest, fork from your repo that you're all working on. And essentially what this means is we are taking, hours a week off, shaving that off for the developer population inside of Microsoft. And it also makes it much easier to maintain multiple boxes, right? How many of you guys not only use your main tower, but you also use, maybe 2 or 3 additional VMs that might be hosted in your lab or something like that for a legacy code base, or to go investigate something that's been deployed, or you need to investigate a bug for production and you need to reset up the dev box again so that you have so that your enlistment actually matches what's been deployed. So this really takes care of a lot of that. DevBox is basically cloud-based, cloud-hosted environments for developers that are optimized for developers. They're also more cost-conscious than just buying, the high-end hardware for everybody. Because DevBox allows you to scale to the hardware that you really want to target, because we basically have the entire Azure, inventory of machines available to you as developers, it means that you can scale up, scale down as needed, depending on your workload. And it also means that these machines can go into hibernation and they can turn off when you're not actually using them. And that also delivers better costs as a result. And of course, they're also managed and secure. So they're managed just like any other cloud PC, any other Windows 365 using Intune and Endpoint Manager. Now, so we talked about optimizing the developer experience and how to deliver that. Now let's talk a little bit about accelerating teams. So, we are, as I mentioned, in a hybrid first world where dev teams are really geographically distributed. And it's really hard to set up a developer environment for a team for everybody on that team, especially when you're geographically distributed. I met a guy 2 years ago as we started working on this project who was telling me about how, he had his team in the New York region, and then he had another team that was based in India. And he did not want to explain to his developers based in India how to set up the dev boxes because it was just too costly for him to actually explain how to do that. So instead, what he chose to do was to have 6 towers under his desk and have them remote into them because it was that costly. I met another guy who was working on a startup, and he was telling me that, they had the size of the room, but he didn't want to expand the room. He didn't want to expand his team beyond the size of what fit into his room because it was too challenging to collaborate with somebody who was down the hall, that literally he felt like he needed everybody to be in the same room with him. Now, these might be a little bit extreme, but I think it really just underscores how painful it is to collaborate, especially when it comes to setting up environments. And when you think about, what it takes to actually create that consistency and the, make sure that there is consistency across all of your developers, how many times have you encountered an issue where it wasn't, it works on my machine, but rather it repro'd on my machine? And now you're working with another developer and they can't repro the bug. So how do you actually collaborate on that issue? How do you make sure that, your developer environment matches what's in the test environment, and that ultimately matches what's deployed to production, and that every developer on your team actually has that same environment? That is essential for resilient and reliable infrastructure today. And especially as we think about, cloud deployments, that really starts to be table stakes baseline for what everybody should be aiming for, is that you have consistent environments across your entire development team and lifecycle. So how do we do this? So, DevBox really allows you to have a project-to-project basis for your developer machine setup. And so you define this with, what is the source code that you need, but then you also have build artifacts, build pipelines that actually just then get replicated. And all of this is done via infrastructure as code. And further, we can also make it self-service so that developers can actually go up to a portal and instantiate not just a dev box, but an entire engineering pipeline to then, work on their code, check in a PR, get that up to test into production. And so they do this through managing these things called dev centers. And then that also allows you to manage who gets access to all of these different resources. Now, we talked a little bit about DevBox, but the reality for a modern cloud native application is that it's not just about setting up the developer box and all of the SDKs and the tools that you need to develop your application, but also all of the resources that you need to build that cloud native application. If you think about a modern application like the podcast app that we showed in that last demo, it uses a database and it uses a log analytics workspace and it has SignalR, and all of these things are different resources that need to be instantiated so that you can actually test that solution. Now imagine every developer on your team needs to set up all of those environments. That's a little bit of a nightmare. So how can we actually make that so much easier? It's also likely that, if you give the power for every developer to be able to instantiate each of those resources, it increases the security risk because your surface area is also larger. So again, having these kinds of controls are what allows you to create much more secure and resilient and consistent environments for all the developers on your team. So We do all of this based on the principles of GitOps. Now, GitOps is kind of the idea of using Git as the single place where we operate. We have everything declared in a file, infrastructure as code, that basically describes the environment. And we use Git history to actually version all of the changes. And then you use agents that automate all of that flow for you. So that allows you to create really consistent environments for all of your developers. So here's what it looks like a little bit in action. Starting with the dev infrastructure, a platform engineer, that's somebody on your team who really works on what the developer experience looks like for your dev team, they create an environment templates. And then they map the projects into the subscriptions and the identities and the permissions that you need for your particular project. And then from there, dev teams can assign roles within the dev team so that they can, be enabled to deploy, to provision new environments on demand. And then all of that gets updated either manually, they can go to the portal, or they can use the CLI to basically create new, let's say they wanted to create a test stamp for their solution. They can do that because they have the permissions to be given that. Or it can also be automated through just Git interactions. And so that then allows you to have all of these resources be automatically provisioned and deprovisioned. Deprovisioned is really important for your dev, test, and production environments. And the deprovisioning is super important because that is one of the keys to how you make sure that you keep your costs down for cloud resources so that you're only instantiating the set of resources that you need when you're actually working through, this particular environment. So let's see it in action.
Hey friends, I'm Scott Hanselman. In this video, I'm going to be introducing Azure Deployment Environments. This is a fantastic new Azure service that lets devs spin up an app's infrastructure from templates. But the templates are secure, they're compliant, and they won't run up a huge bill because they're going to be managed centrally by your team lead or your dev infra admins. So what's the problem that you might have? Let's say I'm a .NET developer, I'm working on this podcast application, and this particular application needs a complex infrastructure to run. How complex? This complex. Okay, it's got Kubernetes, it's got Azure SQL, it's got storage accounts. All this stuff needs to be set up. This is pretty typical for a complicated application. If I was a developer joining the team, having to set up this environment on my own, I could make a mistake, I could open up a security hole. It's overwhelming, and setting up this kind of infrastructure is not what developers want to do. And enterprises don't want developers to have this much control. You can't have anybody creating resources whenever they want to. So how do we solve this problem? We solve it with Azure Deployment Environments. You deploy the right environment for the developer, and they just start coding. Here's how it works. We're in the developer portal, maybe at the command line. I say new environment. I put in some basic details. I'm going to pick the kind of environment I want. I can even have an expiration date to make sure that I don't accidentally keep a bunch of Azure resources around. I don't want to waste any money. They'll get deleted automatically when I'm done with them. We'll pick from a template. Notice here we've got different templates. I'm going to pick podcast app resources. These for infrastructure as code, infra as code templates. Could be ARM, could be Terraform, could be Bicep. I'm going to pick one of those. We're going to make our environment, put in a couple of details, and look, here it is. And I, as a dev, was not asked to provide any subscriptions, any resource group details. I just said I want to work on the podcast app. And look at this, 12 resources. 12 resources got created. All the information that I needed was created in minutes, and all these resources are compliant with the enterprise security standards of my team. So now I can test, I can develop. I don't have to worry about the details of that intricate environment that we saw before. I can redeploy and delete the entire environment. All those resources can come and go. I have full control, and my enterprise team has full control as well, managing all of those complex dependencies. But I would really prefer to be in GitHub. What if I could just make a new branch? I'll make a branch the way I always do, make some changes, click on Actions, and here we can see that Azure Deployment Environments are actually integrated into my Git flow. The entire environment is going to be created as a part of my branch. It's going to deploy the app code to that environment. And look, I'm going to get a custom URL specific to me and my work. I, as the dev, have a dedicated environment and a dedicated URL, which means I can see this live in an environment just for me. I can identify and fix issues sooner, and then when I'm done, I delete the branch, and the entire environment and all those resources gets deleted automatically. Absolute game changer. We can even integrate it with pull request flows. Someone does a PR. I see a deployment environment gets created. They get their own URL. The code reviewers can see what they're doing. They merge it, and again, the pull request gets merged. The environment gets deleted. Again, where's all this being managed from? Well, those environments are being fed from a code repository that the admins set up for the team. And that allows the admins to have control over the type of environments that a dev can create. The admins can define different types of environments. Dev, test, production. They can control who can create and when they can create these things. They manage all of the managed identities, the permissions, they manage the resources and subscriptions, and I, as the dev, just worry about the code. It's a great, great system. The developers create the environments in the dev portal or the CLI or via GitOps, and then those deployment environments provide the ability to track and review and manage all across sub-organizations and dev teams in one central place. This means you're tracking costs, you're tracking security alerts with the right context. Absolutely brilliant. You can check this out at aka.ms/deployment environments. This is an intuitive self-serve system for development teams, Azure deployment environments. It's really going to help enterprises take it to the next level. This is the promise of the cloud. It's scale and elasticity for your engineering systems. We hope that you check it out. Thanks.
First of all, the Azure Deployment Environments is GA now. You guys can go check it out now. It's free. This we don't talk about this quite enough. It's free. It basically it's part of your Azure subscription. So, we just want to make it easier for you guys to manage building out your Azure infrastructure. If you use, ARM and Bicep as the way that you describe your deployment environments, that's great, works great. It also will work with Terraform. If you don't use GitHub, let's say you use Azure DevOps as your developer environment, it also works with Azure DevOps. So there's kind of no reason not to check it out. It really will help you and your team kind of manage all of the cloud infrastructure that you need to work on. It is an early product, so as you do check it out, please give feedback our way, and if it's not meeting your needs, let us know. Microsoft DevBox, which we talked about a little bit earlier, is also GA, available for you guys to pick up and start using right away. And as I mentioned, over 10,000 of our own internal engineers use this product today. And Azure Deployment Environments is also available. I think we're going to skip the GM example just for time. So, we have a great video.
GM's purpose is to pioneer innovation that moves and connects people to what matters.
We're adding so many different new products and services. The need to be able to get people up to develop quickly is becoming more and more important every day.
We have to make sure they have the right tools, the process, the security.
The Microsoft Developer Cloud to us is that all-in-one solution.
Copilot is something we just rolled out. We have 400 plus GM developers using it.
The developers love it. They put comments in your code, and Copilot provides you with example code in the context of your application. So it really understands your application and what you've been writing.
And it lets us speed up a lot of that boilerplate process. Get you, 98% of the way there. That's been a big productivity boost for them.
What DevBox allows you to do that we couldn't do before is really get the developer ready to develop within a day. So all the tools, all the capabilities connected to all the endpoints they need to do their job.
Each DevBox can be configured with a different set of tools. So if you are working on multiple assignments, we have been assigned with multiple DevBoxes.
Azure Deployment Environment is part of the DevBox portal. We are using the infrastructure as code within the deployment environment. Say, I want an environment to test out once I'm ready. I can do it with Azure Deployment Environment. I can spin up that environment, Team can come in and test their code, make sure it's all ready before I move to production.
To innovate new capabilities that really connect people to things that matter, you have to be with the partner who thinks with a developer mindset. That makes Developer Cloud a really good choice for us.
Awesome. They've been great customers, great early adopters, giving us fantastic feedback as we've been building all of these products. What I really love is that they talked about how it helps you onboard developers fast, how it allows you to quickly automate mundane tasks that you don't really want your developers to have to think about, and it allows them to really scale in a way that has real impact on their customers, their time to market, and ultimately their bottom line. So the next thing I want to talk about is security. Now, I think how many of you guys have ever had to respond to a security incident in your career? I would assume that most people in the room would raise their hand. Because the fact is that security incidents are becoming much more prevalent. And part of this is because open source is also becoming more prevalent. And so we're all actually using a lot of the same components to build our code. There's a lot of obvious benefit that brings because we get to build on the shoulders of giants, and we can all, we don't have to rewrite that utility library again and again and again and again. We can all kind of work on the same, open source repository to make that better. But it also creates basically a supply chain that now you're actually inviting, thousands of other developers into the supply chain for your applications. And anytime there is a security incident, the result is, that if it actually makes it out into production, that is incredibly much more expensive than if it was caught earlier in the development process. And so what we're trying to focus on is this idea of shifting left, that shifting left earlier in the developer process, the detection of security issues, the remediation, and ultimately, the quick fix for, so that developers don't have to become security experts, or they don't need to become experts in, how do I query code to understand if that pattern is showing up in my code base. And then also, how do we know what is the right fix to that particular security incident and vulnerability? And so how can we actually create more of a industry-wide expertise around how to respond to certain categories of CVEs? So we've been really working on making sure that we have a common set of tools, common databases of CVEs, but also shifting left that experience into the developer DevOps tools that you all use so that we can make the developers respond to that much earlier in the life cycle. So, we ultimately not only want to apply the idea of shift left to security, but we also want to apply it to things like resiliency and the overall quality of the applications that you're working on. If I can detect that I've checked in a performance degradation into my application, I want to know about that early. If I can detect based on load testing that my app is not going to be able to scale when there's the, what do you call it? What's the shopping day after Thanksgiving? Black Friday, thank you. How do I make sure that my application is going to scale to the load that I am expecting for Black Friday? I don't do a lot of online shopping, as you can tell. All right, so let's take a look a little bit at what I'm talking about here.
I'm now ready to start adding code into my podcast application. So I'm going to jump into DevBox and open up Visual Studio and start developing. First thing I'm going to do is make some changes to this category service. And we have a new method here that basically returns custom category information based on the user preferences. So I've invoked the code here and I've added it into my program.cs file. So we're good to go. All I need to do now is commit these changes and push it up into my Azure DevOps. Now, when I push this, notice that it seems like we have an error. So let's see what's going on. And it looks like I have inadvertently exposed some secrets in my code. In fact, it even tells me right here that's in my program.cs file and gives me more information as to what was going on. Now, all I need to do is go ahead and scroll up to that line of code in my program.cs and see where it's at. Oh, there it is. It looks like it's a key I was using during development for the test service. All I need to do now is remove it so we don't expose that key, and we can commit that again. And now let's go ahead and push it again. And sure enough, there's another error. It's because it is still exposed. That's because GitHub Advanced Security for Azure DevOps recognizes that the exposed credential is in my commit history. So I can't just save the commit and push again. It's a fairly common error that developers make, and GitHub Advanced Security for Azure DevOps is here to save me. So let's go ahead and squash those commits by looking at the commit history. And here, this will be great because I can squash it so the credentials don't get pushed into the repository. So let's go ahead and squash those in Visual Studio, and I can recommit that code and push it up into Azure DevOps. And this is great, and this has gone ahead and saved me from exposing any secrets at all. Now, with all the code pushed up, this project was set up with an Azure DevOps pipeline to run every time a new branch was pushed to the repository. This pipeline will create, using Azure deployment environments, a dedicated set of infrastructure for that feature branch and the code that has been created in the branch. Using AZD, or the Azure Developer CLI, it will deploy all the code and deploy all the infrastructure. My DevOps pipeline was successful completing the run and even unit tested my application that I deployed. But notice that it didn't run the load test. That's because this is a feature branch, and we only run load testing when a PR is open against the branch. So let's go ahead and do that now. When I create the PR, this is going to kick off the pipeline that's going to create a new set of infrastructure that will build the code, deploy the code into the provision infrastructure using Azure deployment environments, run the load tests in my Azure deployment environment, and then this will go ahead and do it in my test subscription versus my dev subscription, which is really great. And the pipeline here is going to run the PR build, and when it's finished, we can see that it is not successful. Now, going into the pipeline run, I can see that it's because the load test has failed. Remember, there's a PR build, and our platform engineering team has established a policy that says load test must pass before things can be merged against a certain threshold. Going into the Azure portal, we can quickly diagnose this and even take a look at what specifically is going on in the category API. This is going to let me go back into Visual Studio and see if I can fix the problem. Now here, this is where I could use Copilot to get some suggestions on how I might be able to make this code more resilient. Now here, Copilot suggests that we use Poly to add retries as well as a circuit breaker. And with a little bit more investigation, I can insert that code so it looks just like this. Now that my code is all set up, we can go ahead and commit that. And hopefully this will solve my performance problems with the load testing. And we can push that off and trigger the pipeline for this feature branch. Now, looking at the PR, I noticed that the code that I put in has caused it to succeed, which is awesome. I could go into the details again and see what was going on and take a look to clearly see that the circuit breaker has kicked in and protected my get categories call. Implementing your platform engineering practices using dev boxes and deployment environments, you can ensure governance and adhere to your engineering standards while providing your teams with autonomy. This accelerates developer velocity and improves quality of your applications.
Awesome. So, in a sense, that is kind of like everything culminated together, right? We can actually bring the developer box and the Azure deployment environments with the pipelines to make sure that they're all consistent. And I can set up those pipelines in such a way that they run the load tests at the appropriate points, that advanced security is set up for every developer without having to teach them how to do the configuration on their own box. And so it just really makes for consistency across your entire development team so that you can shift left that experience. So all of these, issues can be found much earlier in the developer process. So you saw there mentioned GitHub Advanced Security for Azure DevOps. GitHub Advanced Security is a capability that came out in GitHub about 2 years ago now. It does code scanning to look for vulnerable code patterns. It does secret scanning to look for, transparent secrets that are in your code. And it does dependency analysis to detect if you have a dependency on an open source component that has a known vulnerability. All of these are incredibly useful. It was only available to GitHub until, about a month or two ago, when we announced that it's also coming to Azure DevOps. This is in preview today, but, public preview. So everybody can go and try this out, kick the tires on it. Let us know if it's working for you or not. Give us feedback before we push it into GA. You also saw Azure load testing demonstrated there. We actually GA'd this much earlier this year, I think in January, if I remember right. But really, we need to get into this era where we empower you all to test the quality and the resiliency of the complexity of the applications that you are all working now that you're kind of moving applications into the public cloud. Now, I talked about accelerating teams. The last chapter I want to talk about is just building intelligent applications. And, we all know that we've all seen some truly mind-blowing AI applications, AI demos over the past year. And I think there's a stampede, in a sense, for everybody to go figure out, how can I incorporate AI into my application? And the gist of this is that it's a lot easier than you might think. In fact, if you have an API, that's actually a great place to start. So, let's first talk about this in the context of .NET. I just want to kind of reaffirm that our vision for .NET is staying firm. We know that we want to build a unified developer platform for developers that has the best-in-class runtime that works across modern workloads. So whether you're trying to build a mobile application or a game or a cloud-native application, that .NET, we want to make sure that it is competitive, it is the best developer application runtime that it can possibly be in all of these different categories. And we also need to make sure that we have a unified ecosystem, that all .NET developers get to benefit from each other, that there is a unified component ecosystem so that everybody is using the same latest and greatest frameworks as much as possible. And then that it's really easy for you to define and create not just API endpoints really easily, but also all of the different clients that we talked about earlier, not just mobile applications, but also web applications that are really rich, and that you can do this without having to kind of become a deep expert in a brand new domain, that you can use the .NET skill sets that you've already amassed to go and apply that to the domain that you want to build your application for. So, .NET has actually had fantastic momentum over the past couple of years. It's used by more than 6.1 developers, and we're seeing them adopt the latest version of .NET faster than ever before. And the other thing that I really love about the work that we're doing in .NET is that every release of .NET has dramatic performance improvements. And so what that means for you, for the deployed applications that you've already built, they're just going to get faster as you adopt the latest version of the .NET runtime. So, what we're trying to think about nowadays is, how do we make sure that .NET is really fantastic for cloud native scenarios? Now, what do we mean by cloud native scenarios? Really what we see often is that, cloud native scenarios start with containers as their runtimes, that they're often based in microservices-oriented architectures. That's kind of the essence of what a cloud native application is, and that it's obviously also using cloud-based resources to build that application. And so, we want to make sure that we have the best services to make it easy for you to build those types of applications. Now, I'm going to talk about two services that Microsoft builds to empower you to kind of, for your appropriate workload for the application that you're working on. We have Azure Container Apps, which is the best solution, the best service, if time to market and developer experience is really what you're driving for. And we have AKS, which Azure Kubernetes Service, which is really the best if you want to plug into the Kubernetes ecosystem. You want to use the Kubernetes APIs, and that's really what you're focused on. But and also the control, if you really want to make sure that you're able to tune it for the performance that you're looking for, and you need that level of control to be able to support the scale that you're looking for, then AKS might be the direction that you want to go in. But in either case, we want to make sure that the developer experience is really fantastic for both. So I'm going to skip ahead a little bit because we're almost over time to the demo of this, just how to use OpenAI in your application, in an application that you might have already built. So this should be really very easily translatable to you. So really, if you think about it, intelligent apps are really all about taking your data and then transforming it and making it available to the AI so that it can then be exposed in your application, and then your end users can benefit from the intelligence that's inherent in the AI, kind of like what GitHub Copilot does. So first, we can feed the app any data. In this case, we're going to be feeding it the health insurance plan data for a health insurance company. And then we're going to put that into Azure storage. And then we want to be able to run that through cognitive search so that we can index that application and all of that information. And then that's going to be fed into our own OpenAI service so that we can actually make an intelligent application that allows you to take the context of what was in that document and then surface that to the user so that it has the context of that particular document and really your entire knowledge base, and then it can serve that up to your end users. So let's see this in a demo.
Here's our app written completely with Blazor and .NET. And we can ask it questions about our data. In fact, only our data, the things that we fed it from cognitive search into OpenAI service. Now I can chat to it, or we can just use our voice directly and ask it, what is my deductible? And here I was able to use speech APIs to convert my voice to text. And then it's going to query our backend service, and it's found that the deductibles were. But more importantly, it links directly to a document where it found the data. And we aren't making this up on the fly. It's directly from the data. Now we can also build up a search history with OpenAI. Let's take a look at the app again, but use one of the predefined questions. Here, this is going to go out and query it again, and an answer is going to come back, again, referencing specifically some of our data, this case in a PDF. But it's also going to ask us about additional follow-up questions that it will prompt us to go and ask. And we have now built up that history, asking it that data with the OpenAPI service. So how did we build this? Well, we have our app completely written in .NET and Blazor and backend APIs. These are all packaged up into containers that are then running in Azure Container Apps. And then here you see the additional services that are core fundamental parts of this application that are leveraging different Azure services. Now, this application is completely open source in GitHub and is powered by .NET. Now, inside the repo, you're going to find an infra folder, which means it supports AZD, or our Azure Developer CLI, as a way to deploy to the cloud. Why is this important, you may be asking? Well, we've always had the ability to pull down a repo and publish it to the cloud. But what about more complex applications like this one, a cloud native app? Well, with AZD, it makes it a breeze. And with the portal, you can easily deploy it with a few clicks. Now, inside the portal, you're going to see that there are a few different pre-built samples that you can go ahead and deploy. But we have our own code, so all we need to do is just start deploying. Here, all we need to do is then select our organization, our repository, and our main branch to deploy. Now, what the Azure portal is then going to do is it's going to go off and it's going to analyze this GitHub repo. And here it's going to find our infra folder and that we can deploy it with the Azure Developer CLI, or AZD deployment. Now from here, there's a few other things that we're going to need to fill out, like our app space name, the subscriptions we want to use, and sort of additional data where you want to deploy your application. And this is important because we're going to be deploying the entirety of the application. So not just the front and the back end, but all of the other pieces that are required. So here we can see that AZD is now being used to set up our job from our YAML file that was created for us. It's going to check out the code, it's going to build, it's going to deploy everything that we want, and it's going to create all of the resources for us automatically. Here we already see the Azure Container App environment app for our main front end and back end automatically spun up. And then additionally, as this is being run, all of the additional GitHub action steps are being run, and those resources are being deployed, including storage, Key Vault, and so much more. In fact, we can see it under monitoring. We have application insights and logging, and all the additional services that the application is using. And that's how easy it is to get started building applications and deploying them.
Awesome. A little cut off there, James. Thank you, James, for doing the voiceovers on some of these things. So one of the things that I think, that also showed, in addition to just how easy it is to actually use the OpenAI APIs to build your application, is also just how easy it is to actually use the infrastructure in the samples, because we're essentially using the same infrastructure as code patterns to declare the pipelines for how to deploy all of those applications. And then you can use those to actually be incorporated into Azure deployment environments so that you can drive consistency across your entire developer experience. Access it from the CLI, access it from the portal, access it from the developer tools. It's all internally consistent. So with that, hopefully you are all inspired to go think about how you might be able to incorporate the OpenAI capabilities and the latest and greatest AI capabilities overall into your application. So with that, I just want to thank you all for being here. Like I said, I've devoted my career to developers. And as you can see, there's a lot of effort and energy that we put into really tuning every single second of your day so that you can be as productive as possible. Thank you all for coming. I'm happy to take some questions afterwards.